Plant health problems result from 1. Plant pathogens causing diseases, 2. Insects damaging the plant, or 3. Environmental factors often referred to as abiotic disorders. Unfortunately, the symptoms for these health problems are often very similar. A good approach to identification of plant disease is to begin by deductively eliminating insect damage and abiotic disorders as possible alternative causes. I'm Dr. DeBusk, and in this video, I'll cover insect damage and various abiotic disorders and symptoms. One of the reasons to consider insects early in the identification process is the relative ease with which they can be found. Many insects, such as caterpillars and beetles, are fairly large and easy to spot, as is the damage they cause. Even smaller insects like scales and related arthropods such as mites can be readily seen with a 10x power hand lens. Insect damage is also conspicuous, often consisting of holes in leaves or fruit, leaves with a ragged appearance due to insects chewing along leaf margins, or deformed leaves. Signs that insects are or have been present include frass, the dark colored droppings they leave behind, and sooty mold associated with sucking insects. Sooty mold is the black superficial growth of a fungus on the honeydew or other material excreted by sucking insects, such as aphids or mealybugs. The fungus growing on the excretion is not harmful to the plant. When sooty mold is found, you should examine the plant more closely for the presence of insects such as aphids, using a hand lens if needed. Every effort should be made to observe definitive evidence of insect involvement with the plant health problem. If a thorough search consistently yields negative results, then the next step in the process of elimination is to consider an abiotic cause for the plant health problem. Because most plant pathogens require specific environmental conditions in order for a disease to develop, information collected to determine whether there is an abiotic disorder will also be useful for making a disease diagnosis. Moreover, some plants are more likely to suffer from abiotic disorders rather than plant diseases, so taking abiotic causes into consideration first may make the identification process less time-consuming. Abiotic literally means without life. Abiotic plant disorders are non-biological factors usually associated with the plant's environment that affect plants adversely. These environmental factors include temperature, moisture, soil pH, air quality, light regime, and nutrition. If one or more of these factors goes above or below the optimum range for a given plant species, plant growth might be abnormal or adversely affected. Abiotic disorders may also be caused by human activities such as pesticide and fertilizer applications. One important indicator of an abiotic cause for a plant health problem is the distribution of the damage within the environmental unit. Plants generally grow in distinct environmental units, such as crop rows. Environmental problems are much more likely to affect most plants in the environmental unit uniformly. Disease and insect problems, on the other hand, tend to occur in clumps or hotspots within the unit, especially early in outbreaks. For example, if frost injury occurs in a vegetable garden, all 12 tomato plants are likely to have blackened leaves. A fungal pathogen, in contrast, may produce similar dark discoloration, but only 1 or 2 plants in the early stages of the epidemic. Before describing symptoms of abiotic disorders, 2 terms should be defined. Tissue exhibiting chlorosis has lost chlorophyll, the green plant pigment, and turns various shades of yellow. Necrotic tissue is dead tissue, and leaf tissue with necrosis will turn brown or gray. Many fruit, ornamental, and to a lesser extent, vegetable plants grown in Florida are quite sensitive to cold weather. This is especially true of plants that are native to tropical areas such as papaya, begonia, and many palm species. Therefore, it should come as no surprise that these plants are frequently injured by low temperatures. This damage may even occur above 32 degrees Fahrenheit, 0 degrees Celsius, on particularly cold sensitive species. Freezing temperatures damage plants by inducing ice crystal formation in or between cells. Cell membranes rupture on contact with the sharp edges of these crystals. As large numbers of adjacent cells die, the damage, necrosis, becomes visible to the naked eye. Hence, a primary symptom of frost or freeze injury is areas of necrotic tissue, especially at leaf tips and margins. Excessively high temperatures cause plant proteins to become denatured and coagulate, making tissues dry out and die. Whitish, papery appearing areas on leaves are often a symptom of heat damage. Moisture extremes may also adversely affect plants. Wilting results from insufficient plant water uptake because of either a plant disease or inadequate soil moisture. As a visual sign that wilting is a result of inadequate soil moisture, a cross-section of a wilted plant stem will show more or less healthy-looking vascular tissue in light colors, off-white and herbaceous plants, light brown and woody plants. The stem tissue of plants wilted due to disease is usually dark-colored. Drought symptoms vary depending on the plant species. Common symptoms include leaf tip and marginal necrosis, or an overall dehydration that is usually indicated by a color change. For example, St. Augustine grass suffering from drought will turn blue-gray or green-gray, and the leaves will fold in half longitudinally. Too much water, to the surprise of some gardeners and homeowners, may also be a problem. Edema, which occurs most often on ornamental foliage plants with thick leaves, is a specific disorder caused by too much water. Prolonged periods of overcast, rainy weather lead to reduced evaporation of water from plant containers and reduced natural water loss transpiration from leaves. However, if water uptake from the roots remains the same, plant leaf tissues can become engorged, leading to cell rupture and producing brownish lesions that resemble leaf spots caused by living pathogens. Plants that sit in waterlogged soil long enough can actually wilt, will lack vigor, and develop light green or pale yellow-green areas in leaves because of root oxygen deficiency. Oxygen-starved roots do not function properly and are unable to withdraw water and nutrients from the soil. Of course, wet conditions also foster the development of root rot fungal diseases. Each plant species has a light preference. Some plants thrive in shade, while others require full sun for optimal growth. Sun-dependent plants grown in a low-light regime produce less chlorophyll and develop a leggy or spindly appearance because of the stem length between internodes becomes longer than normal. This is often a problem with houseplants that do not receive enough light. Potted tomato plants grown in containers on patios that only receive direct sunlight for limited portions of the day during winter months may also show these symptoms. Not only will these plants appear thinner and taller than normal, they will also droop considerably under the weight of a normal fruit load. On the other hand, plants will also become sunburned. If a plant is transplanted from a shady to a sunny location, the old leaves may develop large necrotic areas in the leaf center from the sun exposure. Leaves that develop after transplanting will be better adapted to the sun. Sunburn is damage to bark, fruit, foliage, and other plant parts caused by excessive exposure to solar radiation that heats and dries the tissue. Sunburn damage can often occur after a windstorm if the shade coverage is lost in the landscape. Keep in mind that some plants are not well adapted to full sun and will never look normal in sunny locations. Proper nutrition is important for plant growth. The major elements are macronutrients, nitrogen, phosphorus, potassium, and magnesium, as well as a host of micronutrients such as iron, manganese, zinc, and boron must be supplied within a specific dosage range in order to avoid either deficiency or excess of any nutrient. While each plant species has different nutrient requirements, the following is a list of the most common nutrient deficiencies in order of relative importance observed in Florida on general groups of plants grown in the landscape or gardens. Turf, nitrogen and iron. Palms, potassium, manganese, magnesium, boron, iron, and nitrogen. Broadleaf plants, vegetables and ornamentals, herbaceous and woody. Magnesium, iron, nitrogen, potassium, manganese, zinc, and boron. Phosphorus is rarely deficient in Florida landscapes, with the primary exception being the ornamental shrub Ixora. Because container-grown plants are grown in potting mix rather than soil, they are more commonly deficient in nitrogen and iron. Low nitrogen is usually associated with plants that are uniformly lighter green than normal, especially on older leaves. Broadleaf plants suffering from low potassium levels typically show interveinal between the veins, yellowing, or scorching of leaf tips of the oldest leaves. Palms are especially susceptible to potassium deficiency, but the symptoms are different. The oldest leaves usually exhibit translucent orange, yellow, or necrotic spots. Magnesium deficiency is usually seen as an interveinal or marginal yellowing of the oldest leaves, with the remaining portion of the leaf remaining distinctly green. Zinc, iron, manganese, and copper often form insoluble salts in the soil. Under neutral or to alkaline conditions, pH 7.0 or above, these metals are tied up and cannot be absorbed by roots, which results in striking deficiency symptoms. These deficiencies are usually seen as yellowing of the newest leaves. Manganese deficiency is also characterized by necrotic spotting, streaking, or blotches. Usually the yellowing or necrosis is interveinal, with leaf veins remaining conspicuously green. Iron deficiency can also be seen as an overall yellowing of the plant, which is more severe on the newest growth, the opposite of nitrogen deficiency. Deficiency of boron manifests as tiny distorted growth of young leaves, upward cupping of leaves, and a witch's broom effect, multiple tiny branches at shoot tips. Excess minerals may also injure plants. Toxicity from excess copper and boron are particularly noteworthy. Excess copper or boron fertilizer sprays may result in necrotic leaf spots on leaves and can easily be confused with fungal leaf spots or contact pesticide damage. In these cases, damage is greatest where droplets of the fertilizer spray accumulate, such as leaf tips. If excessive boron fertilizer has been applied to the soil, boron toxicity symptoms include marginal or tip necrosis on the oldest leaves. It is also important to note that plants can suffer from soluble salt injury when rates of water-soluble fertilizers are too high. High soluble salt concentrations in the root zone can burn roots. In these cases, young plants may wilt, suggesting damping off problems caused by fungi. More mature plants may exhibit leaf tip and marginal necrosis, symptoms similar to drought, wilting, or even iron deficiency symptoms. Another type of plant health problem that you may observe is phytotoxicity from pesticides. The pesticides may have been sprayed directly on plants, applied as granules around the base of the plant or to the lawn, or may have drifted over from applications to nearby plants. This type of phytotoxicity may very well be confused with viral diseases or abiotic disorders. Growth regulator type injury can occur on broadleaf plants from absorption of certain herbicides such as 2,4-D and dicamba. Affected plants become dramatically twisted with marked leaf distortion and a shoestring appearance of the leaves. A great range of symptoms are associated with injury from other pesticides. These include bleached, white spots, marginal yellowing and browning, necrosis of leaves, stunted growth, stem and branch dieback, and interveinal or veinal yellowing. Each pesticide and host interaction is unique, but in general, contact and systemic pesticides applied as foliar sprays result in localized yellow or necrotic spots wherever the spray has landed on the plant, although damage is usually greatest where droplets accumulate, such as leaf tips. Systemic pesticides applied to the soil, granules, drenches, etc., affect new growth. It is important that you evaluate pesticide use over the past 3 months on both injured plants and other plants in their proximity. It may be particularly important to note that clients' use of professional lawn maintenance companies. Accumulation of pollutants and their absorption into plants cause plant damage. The toxic accumulation of pollutants cause cell death and disruption, leading to symptoms. Stressed plants are more susceptible to other diseases and pests. Sulfur dioxide is primarily a result of fossil fuel burning for electricity generation and, to a lesser degree, the processing of steel and other ores. Symptoms include bleaching or pigmented necrotic interveinal spots on broadleaf plants and chlorotic spots and bands or brown tips on needles of conifers. Ozone forms when other pollutants, mainly nitrogen oxides and volatile organic compounds, react in the atmosphere in the presence of sunlight. Ozone damages plants by entering stomata and oxidizing, burning plant tissue during respiration. Mechanical injury to plants is caused by equipment driving through a field, such as a sprayer or a tractor. Heavy equipment can cause soil compaction, creating less than ideal growing conditions for crops. In landscapes, parking on lawns or undefined paths can compact soil and cause damage. Mowers and weed eaters can injure the thin bark of young trees, causing the bark to split and die back. This becomes an entry point for disease, unwanted pests, and the sun to scald the bark, resulting in decay, very stunted growth, or death. In summary, there are many different types of insect injury and abiotic disorders. The symptoms of some may be confused with those of infectious crop diseases. Proper identification is important in making informed management decisions. Herbicides, fungicides, and insecticides will not help with dealing with non-infectious disorders. Some types of injury can be remedied and some cannot.